Section 4.4, Atomic Number and Mass Number. All of the atoms of the same element always have the same number of protons. This feature distinguishes atoms of one element from atoms of all the other elements. Atomic number. The atomic number of an element is equal to the number of protons in every atom of that element. The atomic number is the whole number that appears above the symbol in each element in the periodic table. The atomic number is equal to the number of protons in the atom. The periodic table on the inside front cover of this text shows the elements in order of their atomic number from 1 to 118. We can use the atomic number to identify the number of protons in any atom of an element. For example, a lithium atom, which is atomic number 3, has 3 protons. Every lithium atom has 3 and only 3 protons. Any atom with 3 protons is always a lithium atom. In the same way, we determine that a carbon atom with atomic number 6 has 6 protons. Every carbon atom has 6 protons, and any atom with 6 protons is carbon. Every copper atom with atomic number 29 has 29 protons, and any atom with 29 protons is copper. An atom is electrically neutral. That means that the number of protons in an atom is equal to the number of electrons, which gives every atom its overall electrical charge of 0. Thus, for any atom, the atomic number also gives the number of electrons. Mass number. We know that the protons and neutrons determine the mass of the nucleus. Thus, for a single atom, we assign a mass number, which is the total number of protons and neutrons in its nucleus. However, the mass number does not appear on the periodic table because it applies to single atoms only. The mass number equals the number of protons plus the number of neutrons in a nucleus. For example, the nucleus of a single oxygen atom that contains 8 protons and 8 neutrons has a mass number of 16. If the nucleus of a single iron atom contains 26 protons and 32 neutrons, it would have a mass number of 58. If we're given the mass number of an atom and its atomic number, we can calculate the number of neutrons in the nucleus. The number of neutrons in a nucleus is equal to the mass number minus the number of protons. For example, if we're given a mass number of 37 for an atom of chlorine, its atomic number is 17, we can calculate the number of neutrons in its nucleus. Number of neutrons equals 37, which is the mass number, minus 17, which is the protons of chlorine, and that equals 20 neutrons. Table 4.6 illustrates these relationships between atomic number, mass number, and the number of protons, neutrons, and electrons in examples of single atoms for different elements. Hydrogen has an atomic number of 1, mass number of 1, 1 proton, no neutrons, 1 electron.